All right, last piece of the video. We're actually going to find the inverse algebraically. Here are the steps to finding the inverse function. Do not feel that you must write them down, because if you notice your next slide in your presentation, I've actually copied and pasted this so that you will have it, because I do think it is important to have. You're going to determine whether it's one-to-one or if the domain is restricted. You're then going to interchange x and y. And then you're going to solve for y, or get y by itself. And then you're going to go back and put f inverse of x in for y. So if those seem a little confusing, let's actually try an example, and you may realize that that's not nearly as bad as what it sounded like whenever I just went over them. Okay, so we're looking at two examples here. We're going to find the inverse. And I really want to focus on the algebraic way this time. So we might actually just kind of, I won't say skip over, because we'll look at it on Desmos, but we're not going to graph that one by hand, but we are going to find the inverse. So remember, f of x just means y. So I could really rewrite this function as y equals 2 minus x squared. To find the inverse, step one is to switch x and y. So what I mean by that is, where there was an x, I'm now putting a y. And where there was a y, I'm putting an x. If there were multiple x's in your formula or in your problem, then you would change every x to a y. So you always change both. Okay? So now we want to get y by itself. So step one would be to subtract 2. Then we want to get rid of the negative. So we would divide everything by negative. What that's going to do is change the 2 to a positive, the x to a negative. So I just changed the order to make it look a little nicer. Negative x plus 2 is correct. And then to get y by itself, I'm going to take the square root. Now remember, when I take the square root, I have both the positive and the negative. And so I have two pieces. If we think about what is this, we think, hey, that is a parabola. So if I had, and it's a negative, so that means it's pointed down. So a negative parabola. Well, if I think about turning that sideways to be the inverse, so switching the x and y, I already know that it is not one-to-one. Okay, but I did find the inverse. So the inverse would be f to the negative 1 of x equals plus or minus square root of 2 minus x. Okay, so algebraically, how could we verify that they are inverses? There's a couple of things you can do, and honestly, the easiest way to do it is what we just did. If you're given two functions, is this an inverse of that? Find the inverse of one and see if it matches what the other one's asking you. Like, that's totally okay. But in the proof world, I know that's a scary word because of our memories of geometry, but it's okay, I promise. In the proof world, they typically want you to do the composition. So what is the composition of those functions? And if the composition of those functions, both ways, so function composed with the inverse and the inverse composed with the function, if they both equal x, so it's kind of like question mark x, so do they equal x? And if they do, then they are inverses. So what I'm going to do is I'm going to focus on the positive instead of the negative. I could also do the negative, same thing's going to happen. but square root of 2 minus x is the inverse. I'm going to plug that in, substitute that in to the original function, which is 2 minus x squared. So where there was a x squared, I'm now going to put the function squared. Think about your rules. A squared and a square root cancel each other out. So I'm really just left with 2 minus x. Oh, hold on. That parentheses are important here. And here's why. Oops, I erased too much. Because when I distribute, I am then left with 2 minus 2 plus x. 2 minus 2 cancels out. And that is just x, which verifies that yes, they are inverses. Thinking about what happens if this were a negative. Remember, a negative squared is actually a positive, so I would still, this step would still be the same, therefore proving that they are inverses. All right, what if I went the other way? So the function is 2 minus x squared, and I want to substitute that into the inverse. So the inverse is square root of 2 minus x, but instead of x, I'm going to put 2 minus x squared. Which will leave me with square root of 2 minus 2 plus x squared. Which 2 minus 2 is 0, so I'm just left with square root of x squared, which is positive or negative x, but in this case is x. And if I think about it in a negative sense, that negative times a negative would cancel to still leave me with positive. So this is what it means when it says verifying. So my verifying is all in green. So I did that in green as to, yes, they are inverses because the composition of each other equals x. Another way that you can verify is to graph both of them. So I'm actually curious to see if Desmos does something. So let's check it out together. If I do 2 minus x squared, all right, that's good. I'm interested to see Nope. Okay. I was seeing if there was a plus or minus button, and there's not. So what we have to do is, in 2 lines, we do square root of x minus 2. Oh, I have that backwards. It's 2 minus x. And then in the 3rd line, we do negative square root of 2 minus x. That's how we denote the plus or minus. So really I would change that color to match because we're talking about that same function there. Sure enough, if you think about the line y equals x, let's change that to a dash line. They are inverses of one another because of their points. You could also view their tables to notice that they are inverses of one another as well. So lots of different ways to find out if they're inverses. Trying to decide, spur of the moment here, do we want to do the second example? So here's what I'm going to do. If you understand what's going on, go ahead and try the card sort on your own. You're matching them together to become one puzzle. So one puzzle is 4 pieces. If you feel like you would like to see another example because you need a little bit more practice, I will go over this second one. So make your choice now. And then if you are staying with me, let's finish this one up. All right, so step one, we replace this with y. I'm feeling a little lazy, so I'm just thinking about it as y over top of it, and so I don't have to rewrite it. Step one, switch x and y. And then we want to get y by itself. So how would I do that here? First step, I'm going to add 1 to both sides. Okay, I want to get rid of that cubed root. Remember, to undo a cubed root, I cube it. But if I cube one side of the equation, I must cube the other side of the equation. Then I am just left with y plus 2. Y is almost by itself now. So I have y equals x plus 1 cubed minus 2. If I'm being really proper, I change that y to f to the negative 1 of x equals, remember that's the same thing. So this is my inverse. What if I want to verify? What would that look like? So f of f to the negative 1 of x. So the inverse function was x plus 1 quantity cubed minus 2. When you hear me say quantity, that just means parentheses. I'm going to plug that into the original function, which was cube root of x, but instead of x, I'm going to put the entire function there. And then I have plus 2 and then minus 1 on the outside. All right, so then notice the plus 2 and minus 2 cancel underneath the square root because that's just 0. And then I could do the cube root of something cubed is just itself, so x plus 1. Remember this minus 1 was on the outside. And sure enough, x plus 1 minus 1 is x, which is our goal. Once you get used to doing these are actually kind of fun, but I do know that the first time that you're doing them, they are a little more complicated, and the fact that I just said that they are kind of fun, you're probably rolling your eyes at me, and that is totally okay. I get that. All right, so if I reverse it and do f to the negative 1 of f of x, the original function is the cube root of x plus 2 and then minus 1. And I'm going to substitute that in where there's an x in the original function, or in the inverse function. Oops. Use my parentheses correctly here. And then minus 2. Good. Notice that I can get rid of that second set of parentheses because there's like no subtraction sign or anything crazy happening. I did not want to take out all of that. Nope. Okay. Anyway, I can get rid of one of the parentheses. And then which one did I write wrong? This one should have been a plus here. So these cancel out, and it should be a plus from the original equation there. All right, and then I'm left with the cube root of x plus 2 cubed, and then minus 2. Well, the cubed root and cube are going to cancel out to leave me with x plus 2 minus 2. And yippee, that does equal x as planned. All right, if you wanted to graph them to double check that they were inverses of each other, it would be less work than the previous example that we did. I'll leave that one there. I do have to, let's see, it's not in there. I have to figure out where it's at. There is a cube root. There we go. All right, so a 3 there, and then x plus 2 under, and then minus 1 on the outside. Our second function was x plus 1, quantity cubed, minus 2. Looking at those, thinking about that line, yep, they fold right on that line. So another way to say, yes, they are inverses. So thank you for sticking with me through this second problem.